Let me do this again. All right. So you could skip it. Hopefully you skipped ahead when I went blank for a while. I don't know. I'm sorry about that. I'll put that a note in that. So I'm doing f of t equals 6t cubed. So it's the left end and the right end, the number of intervals, delta x. I'm going to do the same as the last one, 1 to 10, 100 intervals. We're going to do B4 minus B3 divided by B5. Make sure the top is in parentheses so that it does the subtraction before the division. We're going to do n x sub n, mid x sub n. We're going to do f of x sub n. We're going to do the area of the rectangle, the sum of the area, and we're going to do 1, 2, drag it down to 100. So as you can see, I only deleted the first rows from the first attempt, but that's okay. We'll be fine. Equals $B, $3. We're going to take it from the left end. We're going to add, this time we're taking A9 minus, again, we're going to take half of it, times delta x, which is B6. Quick fill that down. We're going to do our function, which is 6 times the column before, B9 cubed. We're going to do the area of the rectangle, which is the column before, times delta x, which is B6 with dollar signs. And we're going to do the sum of the area. So sum, parentheses, D $9, D9. Remember, they have to be in the same row because we're starting at that row. And it will change the second one as it goes down. Okay. And then again, for the area, we're going to do offset. And we're going to pick the title of the row. It says we're going to pick up right after this cell. Okay, then we're going to do the number of intervals. So we want to know how many times we want to go down. Well, we want to go down 100 times. But if we wanted to reuse this workbook, we just want to use that cell reference. And then we don't want to go anywhere left or right. So this answer is a very big number, 14,997.9. So again, this one wanted us to look at taking a graph of the sum of the area and looking at what happens with that. So in that one, this is what happens. The blue is the original function and the red is the new function. And we get 1.5x to the fourth. And you'll see exactly how that happens in the next lesson. Okay? So coming from those four functions is the fundamental theorem of calculus. And in a regular semester, I would make you memorize this. And you would pick one of them and write it on the test. But because it's open book, open note, there's really no reason for me to have you memorize this at this point. So I'm going to have you just look at it. So the first one says we're going to let the function be a continuous function on the interval AB. So if we talk about the last one that we did on XL, our function was 6x cubed. On the interval 1 to 10, and we're going to define that function, an area function, with a capital F of x from 1 to another number from f of t dt. So we would take a different function in there. So, and then if we took the derivative of the antiderivative, we would get the original function back out. On the second one, it starts out the same. And again, it says we take the derivative of the antiderivative, then we get the original function back out. But it also tells us what we should do, provided we get one with numbers in it. If we have actual numbers from A to B, we would then take the antiderivative and plug in B, and the antiderivative and plug in A, and subtract those answers and get a real number answer. And we actually shortcut that by doing Riemann sums. Okay. So let's do a couple problems by hand that you are going to have to do by hand when you get to the homework. Okay, so let's go back to the whiteboard. Let's see here. Okay, so we're going to go to example 10. And we go back to our friend x 4 minus x from 0 to 4. So we did this in 7-1. Okay, and so what's going to happen in these type of problems is they're going to tell you, hey, the function is 4x minus x squared. The antiderivative is f of x equals 2x squared minus x cubed over 3. We don't know how to do that yet by hand, so they tell us what it is. All right, so they're saying, hey, for now, you need to solve this. Plug it into the second piece of the fundamental theorem of calculus and tell me what the answer is. So the second piece tells me to go from 0 to 4, f of t dt, or f of x dx. And then it says take f at 4 minus f at 0. The bigger number always goes first. Okay, but do be really careful about this. These have capital F's, so I need to plug them into the capital F function. Okay, so when I plug 4 in, all right, I get 16 times 2 is 32 minus 64 over 3. And when I plug 0 in, I get 0. So 32 minus 64 over 3, when I convert it all, gives me 32 over 3. Or 10.666667. Okay, so you might get one as simple as this. And then on web work, it will then ask you to confirm using Riemann sums. So you would use midpoint. You would then plug in the lowercase f of x function. And your answer should either match this one or be very, very close. Okay, so you would have a box for this, and then you'd have a box for the Riemann sums answer. Most of the time, they're going to be the same. There'll be a couple times where they're a little bit different. Okay, one last problem. Okay, example 11. Here's the two functions. F of x equals x squared e to the negative x. Capital F of x equals x squared plus 2x plus 2 negative e to the negative x. Again, this one's the antiderivative. Okay, so the first thing it wants us to do is to verify. Okay, in order to verify, we're going to take the derivative of this one, of f of x, of the capital F of x. Okay, so we're going to do the product rule. Okay, so we're going to take the derivative of x squared plus 2x plus 2, which gives us 2x plus 2, negative e to the negative x, plus the top, or the first part stays the same. And the second part, the negative 1 comes down times the original function. Okay? So my negatives will cross off here. Those go away. Now what I need to do is distribute. So this gets distributed here, this gets distributed here. So I'm going to get negative, how did I write it on my paper? Okay, yep. Negative 2x e to the negative x minus 2 e to the negative x. That's the first one. This piece here is now just a positive e to the negative x. Okay, so I get, oops, that's an equals. I get a plus x squared e to the negative x. I get a plus 2x e to the negative x. And I get a plus 2 e to the negative x. Well, look what happens here. Here's this one and this one. And then here's this one and this one. And they're going to cancel out. And I'm only left with x squared e to the negative x, which is what I wanted. This is exactly what I needed up here. Okay, so the next part I need to do is find the area. So find area. 0 to 2. So f at 2 minus f at 0. So again, I'm going to use the capital F. So I'm going to underline this. Remember, capital F. Use the capital F for this. So I'm going to get 2 squared plus 2 times 2 plus 2 times negative e to the negative 2. That's that first part. That part gives me negative 1.35. All right, when I do it for 0, I get, gives me 0 squared plus 2 times 0 plus 2 times negative e to the negative 0, which gives me negative 2. Okay, plug it all into your calculator if you need to. All right, so I get negative 1.35 for the first piece minus negative 2. Do be careful how you plug it in. So I get plus plus which gives me a positive 0.65. Don't forget that the third part is Riemann sums, where you put in f of x, lowercase, into your big Excel workbook. And you should get something close to this. All right, so we'll definitely do a couple of these on Wednesday, and then we'll have a quiz over the whole thing on Friday, I believe. So I'll double check and let you guys know on Wednesday.